Hi all, Dr. Clark here again, and for natural resources today, I'm going to talk about wind energy. So last time we talked about solar energy and the fact that just in the United States we have probably enough solar energy that's coming in just in the United States deserts to generate 7 times the amount of energy the United States uses right now, and we use more energy than any other country. So that's kind of a big deal. So let's see where wind energy stacks up compared to solar energy. So right now there is about 80 million megawatts of wind power that could be tapped worldwide. This is a huge amount of wind energy or potential energy. So that is 5 times the current global electrical generating capacity. So right now. So again, 5 times the total global electrical generating capacity is a huge amount of energy. So, we can replace all fossil fuels with just wind energy. That is if you can tap into that worldwide energy grid. We'll see what some of the issues with doing so are as we progress through. China right now is the world leader, and then followed by the United States. And the United States is definitely increasing their wind power. And right now, wind turbines are operating about 35% efficiency under field conditions. So again, like I said before, this is pretty efficient relative to other things, especially relative to fossil fuels, but especially given that there is no cost to the wind. There is no cost to solar. That it's free. Now, yes, you could argue, well, natural gas and oil is free also. It's free until you run out, and then you have to buy it from another country. You're not buying wind from another country, and you're not buying the solar from another country. So that's what makes it a renewable resource. And right now in Wyoming, China is the world leader, but United States is definitely up in the game. In Wyoming, there is a new field that's going in south of Rawlins, and they're expecting to have increase the size of the field. There's turbines on the field right now, but they're expecting to increase the size of the field in the next couple of years by 1,000 wind turbines. So it's going to be a very big field in a state that has, as most people know who've been to Wyoming, have a state that has a lot of wind. Now, the problem with wind is when conditions are favorable, that you can really create a very cheap energy source. And this is why a lot of people like wind, a lot of countries like wind. The other piece with wind, and we'll talk about it in a little bit, is that wind takes up space, but it's taking up vertical space. So the horizontal space, you can still graze cattle, you can still farm, you can grow crops underneath it, etc. There's a lot that you can do in regions that have wind turbines. But if the conditions are favorable, you can get 3 cents per kilowatt hour. It's probably the best pricing that you can find. Maybe solar will beat it in some situations, but 3 cents is pretty favorable. It's pretty good pricing for energy. So here you can see wind, farm, and you can see that there's a lot of space that is still green around, that you can have organisms grazing, so you could graze cattle, sheep, etc. You can farm these regions. In some regions, depending on the height of the trees, you could probably even harvest trees. You could crop this land, etc. Now, some people don't like the look of this, but I'll tell you, there's a lot of farmers and ranchers in the United States that welcome wind turbines on their property because they get paid to have them on their property. And so normally you can choose either to sell the electricity that's generated, or in other words, you're getting a piece of the profit that's from that wind turbine, or you can just get paid by the company, the electrical company, to have the turbine on your land. And so it's one of two ways in which you can utilize the money from these energy companies. So there are pros. There's no cost, fuel cost, and there's no emissions. There's no carbon dioxide or anything like that being emitted. Now, that's when the turbine is in operation. I do have to say that both with solar and wind and a lot of these other technologies, when you have to build a framework, when you have to build a turbine or a solar system, there is emissions. Okay? It's just an initial emission. So you're going to have factory costs where you're building, the materials for that, whatever that is, either the turbine or the solar voltaic cells, these kind of things. There's going to be emissions coming off those factories, but it's a one-time emissions. Right? So the generation of power is not emitting any, toxins in any way. It does generate income for farmers, ranchers, things like that, so they can sell or rent the land, they can sell the electricity, a couple different ways at which they can get paid. This is a big deal for some farmers in some regions. I mean, I know that the time that I've spent in North Dakota with some ranchers and farmers in that region, it was a make or break. By having the wind turbines on their property, they were guaranteed to have food on the table, electricity in the house, no matter what their crops did. And so this was a huge deal for a lot of farmers in North Dakota to have these turbines on their property because it was a constant source of income. Where farming and ranching, as many people who do this for a living know, that it can be hit or miss. You can have a really bad season where your crops are destroyed or they just don't grow correctly and you don't get a very big yield. And that can be devastating to a farmer. But to have this backup plan where you're always going to have a little bit of cash flow from having turbines on your property, it's a big deal. The other thing is it's really quick to set up. Okay, you really just need to know where the wind source is coming from, and then you just build them, construct them, and it's a really quick construction time compared to a lot of the other systems. What's the cons? Okay, the main con is that wind is intermittent, so it's not always on, and so you'll have situations where you might have a day, 2 days, 3 days, maybe a handful of days where your wind speeds are not high enough to drive electricity. It's not windy everywhere. There has definitely been some bird mortality, and so I'll often have students say, well, yeah, I know this field that I drive past, it's never on. The turbines are never spinning, and it's windy outside. Well, I have to tell you that most wind turbine fields, okay, most wind farms, have a preventative method. They turn off the turbines when birds are flying near the turbines. So especially things like golden eagles, bald eagles, they turn the turbines off. Okay, so they have somebody out there, a job that someone does. They're bird watchers, and they watch to see when birds get near the turbines. If they're within a certain amount of feet of a turbine, they call them up and they turn them off. Okay? So if you're driving past a wind turbine field, a wind farm, and you see that the turbines are turned off, okay, it might not be because they're broken. Okay, they're pretty easy to fix and they're pretty easy to run. It might be because that they're trying to prevent bird mortality. Right? So they don't want to have a bunch of dead bald eagles, golden eagles, because they do occasionally hit a turbine. The other thing is you have to have power line construction. So you have to run the electricity from the turbines. Okay? Most of this is done underground now, but you still have to set up this kind of infrastructure which is needed from these farms. And most of these farms are occurring in regions where there's not a bunch of people, so new infrastructure has to be applied. So where do we see turbines and potential for turbines? Really the middle part of the United States, which is sometimes called the Corn Belt, the Sunflower Seed Belt, the Farmers Belt is really just, through the middle part of the United States. So Wyoming's going to have a piece of that. Eastern Montana has a piece of that. Parts of Colorado. But most of North Dakota, South Dakota, Kansas, Nebraska, okay, Oklahoma, Texas, they're all going to be regions at which you would expect to see a lot of wind energy. And those are regions in which we see most of the wind energy going up. So that's problematic, right? Because most of the people don't live in this region in the United States. Most people live on the East Coast or the West Coast. So the energy that's here is not very readily utilized by people on the East Coast or West Coast. So you need to have infrastructure that can run it to the coast. We don't have that kind of infrastructure in the United States, but we will have to develop it sooner rather than later, because a lot of the energy that we see in the United States when it comes from renewable is solar is going to be in this region of the United States, wind's in this region of the United States, and hydro is going to be in this region of the United States. The renewable resources, the renewable energy, the main renewable energy is going to come from the western part of the United States. We're going to have to ship that and get that to the eastern part of the United States if we want the United States to go renewable. Okay? It's coming, and it needs to be done. That infrastructure needs to be built. So wind energy, the technology is old. It's been around for a long time. I mean, it was used originally to crush grains, drive water mills, things like that. But more recently, it's used to spin a turbine, to use some magnets in opposite fields to create electricity, to generate electricity, and then that electricity can be captured via the grid. Now, wind energy has definitely been on the rise. In 2010, right, we're generating about 200,000 megawatts, okay, worldwide. And in 2012, we had about a 40% increase. Okay. I don't have 2016 here, but we had about another 40% increase between 2012 and 2016. So we're well above 300 megawatts worldwide, and still going. And there's a lot of countries that are moving towards wind energy. Okay, right now the United States, Germany, China has about 60% of the installed capacity. China is the leader. then the United States, but Germany's catching on the United States. They have huge fields that are being proposed, and we'll start breaking ground soon on those fields. So right now, today, the amount of energy created by wind is about 4% of the total worldwide energy consumption is due to wind. So even though it's, it could be 5 times what we utilize, we haven't tapped into the market really. There are reasons for that. Mainly has to do with this intermittent winds. So we want to make sure that we're installing wind farms in regions that the wind is fairly constant, because the stop and start of wind turbines makes it not very efficient. But also we're trying to develop technology, scientists are trying to develop technology to prevent bird strikes, to prevent bats from dying, and to increase the productivity. So to have the turbines themselves, I don't want to say talk to each other, but basically the technology is to have the turbines maximize their efficiency. So if they need to slow down, they can slow down. If they need to speed up, they'll speed up. And so the tension, the amount of friction can be decreased electronically. Okay? So you can put a braking system into the heads, and this can help with generation of electricity. And so this technology is definitely coming about, and will be here in the near future, and most of the new fields have a lot of this technology built in. So we're going to watch a little bit of a video on wind energy, mainly wind energy in Germany, and kind of what some of that technology is all about and how that's going to influence the world's energy market.
The side of the world in a week. So any damage that we do to our atmosphere is truly a global issue. Looking at this wind generator graphic, you can see that wind is all around us. Though we can't see it directly, we can feel it and, well, track it, as seen here.
Of course, we do take advantage of the wind to an extent with wind turbines, but is wind energy actually worth it? Could we power the entire world with just wind? We thought we'd go to one of the countries at the forefront of the wind power movement to find out.
Got your passport?
Back there.
Let's get on the plane!
Okay, so we just landed in Munich, Germany. We're on the Autobahn, and we're on our way to the GE Global Research Center, where we're going to meet some incredibly intelligent people advancing science and research. Specifically, we're going to talk to some about the future of wind energy.
And we're actually here in Munich specifically, which as a city has pledged that by 2025, we'll be running on 100% renewable energy.
The first windmill built for energy was in 1887, but for more than 2,000 years, we've been using wind energy to grind grains and pump water, so this technology is old.
Nowadays, wind turbines are mostly used for power. They don't rely on fuel and emit way less air pollution. As well, power stations and power plants rely on water for cooling, water which us humans need to live, and it's also stuff that's running out. In fact, 14 million liters of water are used every year in conventional ways of generating energy. Meanwhile, wind turbines use none. So how exactly do they work?
Okay, so we're here with Dom, who works at the GE Global Research Center. Greg will be our illustrator. We can use both of these to figure out how exactly do they change lives.
So I think one way one could explain, every one of you has probably seen a fan, right? So we're getting cooler in summer.
I hope everyone's
right?
seen a fan.
So what you do usually, you plug it into your power outlet somewhere, you have your fan, well imagine it would be a fan and it starts spinning, right? And by that it produces wind which comes your way. Now imagine it the other way around, we're just reversing it, right? So the wind is coming at your fan, the fan starts spinning the other way, and then would bring you the electricity back to your outlet.
What about the spinning generates electricity? How exactly does that translate into power?
Right, so that's almost independent of wind. We have a lot of rotating machinery, whether it's in nuclear plants or gas turbines, coal, whatever else you have. You have a generator which has a shaft spinning inside. and which induces a magnetic field and then causes electricity. That could be a gas turbine, or in this case, it's a wind turbine.
Right. Okay. And so then that generated electricity just goes where? Into a home, into
Right.
city, or how does it get called?
Well, most of us don't have them in the garden.
Right. Exactly.
But so that would mean it goes into the grid, and then the utility companies distribute it further.
Okay, so how much energy do they actually generate? In today's world, wind energy represents around 4% of our consumption, which is a huge difference from the late 90s when a mere 0.1% of our energy came from wind. But if you were to take one wind turbine, would it charge an object like your phone, or something a lot bigger like an entire building?
It turns out that a modern wind turbine can power over 1,000 homes. And if you want some hot water, it can actually power 28 million kettles. That's a lot of tea. And it's also the equivalent of 16,000 solar panels. Industry experts actually think that by 2050, we could be getting as much as 1/3 of our power from the blowing wind.
Of course, wind isn't exactly consistent and depends highly on your location. So how do we make wind energy more efficient?
Instead of having individual wind turbines trying to maximize their own performance, we're looking at optimizing the total farm performance. So we have farms up to 300 turbines. So over in the US, and we have a big farm of 200 turbines here in Europe. So
one of the coolest things that we've sort of realized is not only that the turbines can communicate together, but they're actually collecting so much data. I don't know if we can get it on the camera, but you had showed us a video.
Thank God smart people exist. Thank you for existing.
So you see the wind farm here, and what you're seeing here, all these black dots are wind turbines. You see very low winds. The colors represent the wind speed, so blue is low and red is high.
So the wind's
and now
going
the farm is
faster.
producing. Now the farm is producing.
Oh, wow.
And you see these blue streaks behind the turbines. Those are wakes. Meaning,
So yeah, so that blue is showing the slowed down air.
Yeah. So that's the wake. And right now things are all fine. You know, all turbines are kind of seeing free stream wind, and now this one is being blocked by the first one. So what we do now is we can start easing off on the first one to create more power for the pair of them.
Right.
And this one will do it on its own, right? They're all communicating, and someone doesn't have to be like.
There is a farm control system
Right.
that is looking at the whole farm and is telling turbine one, hey, you need to slow down a little bit.
Yeah, so this is like an amazing. People here are so smart. They're figuring out software and formulas to discover exactly how all these turbines can interact with each other, what they need to be doing at any instant, or at least that's the goal, right? Is like, what should this turbine do and should this turbine do? Not only the way they're interacting with each other, but with the environment, right? So.
And you said that this can increase the efficiency by 1%, but can you explain more like financially so people can see the money?
So the value of 1% is hundreds of millions of dollars. And we achieved this in just the first test.
There has been some backlash about how wind turbines affect birds and bats, but to put it into perspective, the glass windows on buildings are actually much more detrimental to bird populations. Wind turbines do still affect birds, so moving forward with the placement of wind turbines, it's important that we focus on putting them outside of bird migratory patterns.
As for bats, scientists have been experimenting with special types of paint that actually show up for bats during echolocation to help avoid collisions. This is another example of how scientists are continually making wind energy better for the environment. So what about cost? Surprisingly, wind turbines are able to compete with other energy sources when it comes to cost per energy output, though this has come after years of improvements in efficiency and technology. And chances are, with time, it's only going to get better and better.
If you ask people 20 years ago about the internet, about wind power, about YouTube, about many of these things, they would say, or cell phones, right, or whatever, they would say, you're crazy, right? But be open-minded, that's my message. And revisit your assumptions now and then.
Okay, so there's just a little clip about a research facility on wind energy in Germany and the ways at which they're trying to increase productivity, but also decrease the environmental impact that wind energy might have on, say, things like birds or bats. This technology is out there. It's becoming second nature. I think most of us have probably been driving on a freeway and seeing a turbine in transit. They're going up all over the United States, and they will continuously go up throughout the United States. Now, 4% today. In the 90s, we're at 0.1%. 10 years from now, even if we're at 8-10%, 10 years from now, we're still making major progress, because that's 10% less energy we need from fossil fuels. We have to, I mean, based on what I showed you before, the life expectancy for fossil fuels is not it's not looking good. Okay? If we're talking about growing up in the 70s and we said, well, we got 100 years before we burn out of fossil fuel, people in the 70s were like, cool, let's burn it. Okay? But now, we're not talking about that. We're talking about 50 years. And most people who might be watching this, you probably have 50 years of life left, or close to it. At least your kids or grandkids have 50 years of life. And we will eventually make it to a point where the world will be without fossil fuel. And we need to have a backup plan. So wind energy is part of that backup plan, and we'll see how it progresses in the near future. Okay, so the next thing I'm going to talk about is geothermal energy and some of the other energies that are less common and more localized. So hydro, geothermal, these kind of things, where we can generate a lot of energy, but it's very localized. It's they either have to happen around rivers, or they have to happen around thermal vents. They have to happen in distinct regions, far less common regions than places that are windy or places that have a lot of sunlight, photons. Okay? So next time we'll pick that up.